For 380,000 years, the universe was a fog, not empty, not dark, blind. Light existed, it just couldn't go anywhere. Picture a soup, hotter than the core of a star, so dense that photons, particles of light, couldn't travel more than a hair's width before slamming into an electron. Trapped, scattered, trapped again. The universe existed, but nothing could see it. Not because there was nothing to see, because the light itself was a prisoner. This is the story of the day the fog lifted, and why that one afternoon, cosmically speaking, decided what every galaxy, every star, and every atom in your body would ever look like. Rewind further. 1 second after the Big Bang, the universe is a plasma. Protons, electrons, photons, all moving too fast, too hot to form anything. No atoms, just charged chaos. For nearly 400,000 years, this didn't change. The universe expanded, it cooled, slowly. And the entire time, light was there, but useless. Every photon born in that plasma bounced off an electron within nanoseconds. It's why, if you could somehow stand inside the early universe with a flashlight, you would see nothing, not darkness, blinding, opaque white. Temperature is the whole story here. At roughly 3000 Kelvin, something changes. Electrons slow down enough that protons can finally hold on to them. This is called recombination, which is a strange name because it never happened before. It's the first combination. Hydrogen atoms form, neutral, stable, and suddenly there's nothing left for photons to bounce off. The fog lifts, light goes free. For the first time since the universe began, a photon can travel not a hair's width, but forever. But here's what almost nobody tells you about that moment. It wasn't uniform. The plasma wasn't perfectly smooth. There were tiny variations, regions fractionally denser than others, differences of 1 part in 100,000, small, almost nothing. But gravity doesn't care about almost nothing. Those slightly denser pockets pulled in slightly more matter, which pulled in more, which pulled in more. Every galaxy you've ever seen a photograph of, the Milky Way, Andromeda, the smudges in a Hubble deep field, started as a wrinkle in that fog. What we actually see when we look for this moment isn't the fog itself, it's the light released the instant it lifted. We call it the cosmic microwave background. It's the oldest light in existence. Stretched, cooled, and redshifted by 13.8 billion years of expansion until it now arrives as microwaves, a temperature just 2.7 degrees above absolute zero. It's everywhere, right now, in this room. A tiny fraction of the static on an old analog television was this exact light. You have, at some point in your life, accidentally watched the birth of transparency. And this is where it gets uncomfortable. Because that light isn't just a relic, it's a map. Every temperature variation in the cosmic microwave background, those 1 part in 100,000 wrinkles, corresponds to where matter would eventually clump. Scientists didn't just find the afterglow of the fog lifting, they found the blueprint for everything that came after. The Milky Way's location wasn't decided by chance over billions of years. It was decided in that first fraction of a second, encoded into a fog that wouldn't even clear for another 380,000 years. The mission that actually measured this, the COBE satellite, then WMAP, then Planck, spent decades mapping those temperature differences across the entire sky. The result looks almost mundane, a mottled oval, blotches of slightly warmer and slightly cooler microwave light. It doesn't look like much. It is, without exaggeration, a baby photo of the universe, taken 380,000 years after birth, the only one that will ever exist. Here's the part that should actually unsettle you. We cannot see further back than this. Not with light, not ever. The fog is a wall. Every photon before recombination was scattered into randomness. The information it carried is gone, permanently, no matter how good our telescopes get. Everything we know about the first 380,000 years, the plasma, the expansion, the fractions of a second after the Big Bang, we know from physics, from inference, from the shape of the fog itself, never from a direct photograph. For decades, this was framed as a limitation, a wall we couldn't see past. But here's what the documentaries rarely sit with. That wall is also a filter. Every irregularity that survived to become the cosmic microwave background had to survive 380,000 years of a plasma trying to smooth it out. Only the wrinkles strong enough to persist made it through. which means the map we have isn't just a record of where galaxies formed. It's a record of which fluctuations were resilient enough to matter. The universe filtered itself before it ever became legible. Every galaxy is, in a very real sense, a survivor of a filtering process that happened before atoms, before stars, before light itself was free to travel. So the next time static crosses an old screen, or a photograph of a boring mottled sky crosses your feed, that's not noise. That's the moment the universe stopped being blind. The question isn't whether we'll ever see further back. We won't. The question is what else, right now, is trapped in a fog, waiting 380,000 years, or 380 seconds, to finally get free.